Check your understanding. Find the work done by the same force in example 7.4 over cubic path. Y is equals to 0.25 m raised to negative 2 times x cubed. Between the same point, A is equals to 0.00 and B is equals to 0.2 m and 2 m. So again, given y is equals to 0.25 m raised to negative 2 x cubed. A is the origin or the 0.00 and B is equals to 0.2 m and 2 m, and our force is the same force in example 7.4. So what are we trying to find is the work done. So solution again, first of all, our y is equals to negative 25 m raised to negative 2 x cubed. So our dy is we're going to use the power rule. So from 0.25 m raised to negative 2 x cubed, mahimo na siyang 3 times 0.25 m raised to negative 2 x squared dx. So now work done is equals to fx dx plus fy dy. So by substitution, we're going to substitute the value of fx, which is 5n over my dx, plus the value of the fy, which is 10n over m x dy. So again, now we're going to substitute the value of y naman. So 5n over m times 0.25 m raised to negative 2 x cubed dx plus 10 n over m times 3 times 0.25 m raised to negative 2 x cubed dx. So ang mahimong answer ana kay 1.25 n over m cubed x cubed dx plus 7.5 n over m cubed x cubed dx. So pag i-add ng duha, ang 1.25 and 7.5 mahimo na siyang 8.75 n over m cubed x cubed dx. So the integral of x cubed is x raised to 3 plus 1 over 3 plus 1. So our integral, or the integral of the x cubed, is equals to x raised to the power of 4 over 4. So the work done is 8.75 n over m cubed times 16 over 4. So our work done is equals to 35 joule. Check your understanding. The spring in example 7.5 is compressed 6 cm from its equilibrium length. A. Does the spring force do positive or negative work? And B. What is the magnitude? So letter A. The work it does is negative. Based on the example 7.5, the spring is compressed from its equilibrium length. Therefore, the spring force is different or opposite direction to a compression. The force that the spring exerts on you is in the opposite direction to its displacement. So the spring has done negative work. And B. Based on example 7.5, the magnitude is still 0.54 joule, but it still depends on the square of the displacement in the given problem. So if ever na iba yung binigay na square dun sa problem, so ayun yung susundin mo. But in this example 7.5, they use the positive negative 6, or diba, which is the positive and negative 6 as for the value of x. So the magnitude is 0.54 joule, like this. Check your understanding. You are rowing a boat parallel to the banks of a river. Your kinetic energy relative to the bank is less than your kinetic energy relative to the water. Are you rowing with or against the current? So my answer here is you are rowing against the current. So, your kinetic energy relative to the bank is less than your kinetic energy relative to the water. So you're rowing a boat parallel to the banks of a river. So it's possible that the motion of your boat is affected by the current of the river, or influenced by the current of the river. So again, your kinetic energy relative to the bank is less than your kinetic energy relative to the water. Therefore, your velocity of the boat relative to the bank is also less than to the velocity of your boat relative to the water. So for me, um, you're rowing the boat in maybe in different direction, or yeah, you're rowing your boat against the current. Check your understanding. Suppose the radius of the loop in example 7.9 is 15 cm and the toy car starts from rest at the height of 45 cm above the bottom. What is its speed at the top of the loop? So based on the given problem, first, our velocity is 0 since it starts from the rest at the height of 45 cm above the bottom. So our y1 is equals to 45 cm, and I convert it into meters, so it becomes 0.45 meters. And our y2, since it is 2 times radius, I multiply the value of 15 cm. First, I converted the 15 cm into meter, which is it became 0.15 meters. So 2 times 0.15 meters, our y2 is equals to 0.30 meters. So we're trying to find is the speed at the top of the loop. So solution, we're going to use the work energy theorem. So with this equation, negative mg times y2 minus y1 is equals to 1 half mv2 squared. So since we have the value of y2, which is 2r, so we substitute that already, and by manipulating the equation, we multiply both side by 2, and after we divide both side by m, and we arrive in this equation, which is at first it become v2 squared is equals to negative 2g times 2r minus y1. And para mawala yung square, we square both sides, so we arrive in this equation, which is v2 is equals to square root of negative 2g times 2r minus y1. So now substitute the value, so v2 is equals to square root of negative 2 times 10 meter per second squared times 0.30 meter minus 0.45 meter. So we have 0.20 meter per second squared times 0.15 m, and the answer would be 3 square root of 3 meter squared per second squared. So since the 3 is not a perfect square, but the um, meter squared per second squared it's a perfect square, so the final answer, or the speed at the top of the loop, is equals to square root of 3 meter per second.